Swayam Prabha. Digital India. Educated India.
In the last class we had looked at the furrow irrigation method, and we had also mentioned that besides those three conventional methods which have become very popular over last many centuries, the border irrigation, basin irrigation and the furrow irrigation. Besides these two methods, these three methods, there are some other methods which are variations of these methods. They are also being used in some places where the situations warrant those methods to be applied, either because of the constraints, the financial constraints, or because of the constraints of topography, or the soil type, or the soil depth. All those things put together, they are, let's discuss two of those methods which we had mentioned in the beginning. These are contour ditch method and the other one is contour levee method. Let's first look at, in the case of contour ditch, what type of layout we have and what it is suitable in which type of situations. Now, this is the figure of a contour ditch irrigation method. You can see here that as there are two ditches, this is one ditch, this is another ditch. So what you have done is that you have laid the ditches. Some ditches, the size of the ditch can also vary depending on how much is the stream size which is possible or which you want to use. These ditches are laid on the contours, and then you, while irrigating the area, you make the openings in the ditches and let the area be flooded. So this is basically a method of wild flooding. This is a method of wild flooding in which you have ditches which can be spaced about 20 to 25 meters and may go up to 100 meters. So the spacing between the ditches can be varying between 20 to 100 meters. That means the area which will be covering from this end to this end can be a wide area in case you have the infiltration rates are lower. If the infiltration rates are higher, then you might restrict the width between the ditches. So that is up to the, you will have to look at many other conditions also, the soil type and then the slope. The slopes in these cases, again the slope variation can be quite excessive. You can use these method of contour ditch on slopes which are as low as 0.15% or even higher slopes. But again the restriction will be that what is the slope along with the soil type which is not creating any erosion problems. As the stream size which you are going to use, they are comparatively higher stream sizes. You are flooding the areas, you can afford to use the higher stream sizes if the areas are flatter areas. If the areas are steeper areas, you might reduce the stream size. So in this method is not basically a method which is a very sophisticated method. You are using this method because of the fact that you want to make use of the existing conditions and you don't want to indulge much expense which is involved in forming the area or grading the area. So the adaptability, if you look at where these methods from the adaptability point of view, you will find this method to be quite useful when you are talking in terms of foothills. Those areas which are lying on the foothills, which are having slight undulations, but not the slopes are not very steep, but at the same time you cannot afford to form these areas or relay these areas because of the fact that the soil depth is quite shallow. So if you try to reform these areas or you go in for the grading of these areas, you will find that the soil, the fertile soil will be lost. You might be having a very small depth which you cannot manipulate, you cannot grade that soil because of the loss in fertility, and as such the depth of soil available is very shallow. Then it is involving very low costs on those accounts because you don't need any. In this case there is no land grading required. The ditches are also unlined, so there also you can save a lot of expenses. Then the labor expense is also not very excessive because the places at which you have to make the openings is not a very skilled thing. With slight amount of experience you will know that at what spacing, because that will be a function of spread of the water, up to which area the water can spread. So it is not a very scientific method, it is only a method which may be used under some circumstances where you don't have any other possibility of using the other method because of various reasons which we have just discussed. Let's quickly go down to the next method of contour levee. Which again is quite similar in terms of the previous method which we had discussed, because in this case also you use this method where the situations or the conditions don't warrant any land grading or land shaping because of various reasons, and in this method you are not using the ditches, but you are using the natural slope which is available in the area. So if you look at this is a strip, which is not a parallel strip as you have in the case of border. In the case of border irrigation, you are trying to make the strips parallel so that you can have a very uniform flow over the strip. In this case, there is some, the slope may be in this direction, there is a gentle slope. So you have tried to utilize that slope, which is in this particular case the slope will be in this direction, because you are supplying the water from some upstream end to the downstream end in this strip, and this strip you have not, you have tried to use the contours. These are the natural contours which might be having some downslope, because unless the slope is there, you might find that the water might not move in the lateral direction, in the longitudinal direction. So you have to have some slight slope, otherwise the size of the stream will have to be very excessive. If the slopes are less, the lesser the slope, to cover larger area you will have to have excessive stream size, but that can only happen if the soil type is conducive to that higher stream sizes. So in this case you have the ridges which are separating, which are going parallel to each other, not exactly parallel, but they are going along the strip, and on this side you are having two ridges which are perpendicular, one ridge here, the other ridge at this location. So this channel can be used to collect the surplus water, which may be used in the next strip. So this is again a method of flooding, where you are not flooding in the same manner as you are doing in the ditch method, where the water was flowing along the ditch. In this case the water is flowing at some field channel which is at the upstream end. So you release the water from there, it moves into this, and then the surplus amount is collected, it might go to the next field. So is normally used where you have the field to field flooding. In areas where for example the delta areas, where you don't have any problem of the amount of water available, in our Kaveri Delta region we are using this method, where you are letting the water flow from one area into another area, and with the consequence that most of the time the water might be standing there. So that is the reason that you are using the paddy. The paddy crop is quite popular in those areas, because paddy needs quite a lot of water, and in this method you can provide that water, because the water is coming from one field going to the next field, going to the next field, and that continues. And this method can also be used for other crops which are not very sensitive crops. For example, the grasses can be, this method can be used. The other crops can be fodder crops. Again, you can use this method. You might not have that continuous supply, you might have intermittent supply, because the fodder crops, again, they cannot sustain that long inundation. So the adaptability of this method again is quite similar, that you are you can use it for those areas where you don't have any availability of excess labor. The labor costs are very less in this case. Otherwise the land farming cost can also be reduced by not grading the areas. Even if there is some problem in terms of the levels, you might, since the depth of water is quite excessive, so the distribution might not be uniform, but at the same time the distribution loss can be compensated by the amount of expense which is saved. So these methods are not a general purpose method, they are specific purpose methods, where you can justify these methods in some conditions, under some situations where either the suitability or the economic conditions of the farmers or the type of crop which you are growing, they are the the major deciding factors. So with that we will conclude the methods which are surface irrigation methods as we had defined in the beginning. We will go down to the next class of irrigation methods which we had started with. Along the surface irrigation method we had said the subsurface irrigation method. In this category of irrigation methods, we are supplying water is applied below the ground surface. So this is the basic difference between the surface irrigation method and the subsurface irrigation method. In the case of surface irrigation method, we have seen that we are making use of the gravity flow, but the water is traveling over the surface of the soil or the ground. Whereas in the case of subsurface irrigation, the water is not traveling over the surface of the ground, but is traveling within the ground surface and below the ground surface. Now, what kind of method this can be? If you just try to visualize, you will find that the typical, suppose this is your ground surface. Now, if you want to make the water, because the root zone depth we know, this is the root zone depth in which we are interested in. We want to supply moisture to the root zone depth, this area, because the plant root system is in this area, and because of that fact, this needs moisture. In the case of subsurface irrigation, there is a way out that the possible solutions are that you either provide some sort of ditch. You have a ditch where you control the water. You have a ditch where you have, this is the water level. Now this water level is under your control. What will happen if you maintain this water level here, and if the groundwater table is somewhere down below, depending on what type of soil you are using, what type of soil is prevailing, there will be some flow from this area into this area. Some water will flow into the zones. Again, it will be a function of how much water will flow. It will be a function of what is the wetness of the soil and what is the relative location of the groundwater table. If the groundwater table is very low, most of the water might go down, some water might go into the lateral direction, as we have seen in the case of furrow irrigation. But this situation, when we use the subsurface irrigation, we are basically using this irrigation when the groundwater table is already quite high. You don't use this irrigation when the groundwater tables are very low, because in that case most of the water which will be making available in the ditches, because this water has to be made available artificially, you have to bring this water from some supply source. This source can be either the canal water, or it can be the groundwater which you have pumped and put into the channel system. It can be any source. So this the level which you have created here in the ditch and the level which is the groundwater table, if the groundwater table is somewhere here, you will find that after some time there will be some level stabilization. If you keep on supplying this water, there will be some flow from the ditch into this area and the water table might come up locally. Now this rise in water table is within your control. If you find, let me put this here again, that if I have a ditch which is a longer ditch, if I have this is the ditch. Now in this particular case, by controlling the level of water, if my previous water table was, this is the water table which I have established after a long, after controlling this level for a long period, you will find that this will stabilize. The water will keep on moving on this side, and depending on the soil type, if the soil type is quite porous, this might be achieved relatively in a quicker manner. Now, if this is the level here which I have attained, it has become quite excessive. I can reduce this level by removing water from the ditch. This will come down. Initially it will be like this. After some time it might become this, and after some more time this will be achieved. This fluctuation is what is in your control, and that is what you do in the case of subsurface irrigation. The design parameters which you have to look at when you design the subsurface irrigation are: what should be the spacing between the ditches, because that will decide up to what level the water table, when you control these levels of water in the ditches, how much time it will take for the water to drop down to the level, desired level, how much time, how quickly it will do that, because that is a function of the soil type. What is the hydraulic conductivity of the soil, as that will decide the movement of the soil, the water into the soil. So depending on the soil type, you can design what should be the spacing between the ditches. You can also design, the other parameter will be what should the depth of the ditch, as that will give you the flexibility on up to what level you can control that the water depth. Then you can also decide on what should be the size of the ditch. So these are some of the parameters which you will design. Now this is one option available, that you have the ditches. If you want to choose another option which is quite a usual option, you might replace these ditches with the circular pipes. You have this, instead of having ditches, you can have underground pipes which are having perforations. The water passes through these pipes and it gets it does the same job as is being done by the ditches. In that case, you can save the area which is utilized by the ditches. So that much area can be saved. In this situation also, again, you will have to decide what will be the depth up to which you have to lay down the pipe, what will be the spacing between the pipes, and what size of the pipe has to be used. So these are some of the parameters which will be needed to design the system, how the system should be laid out, and that will be also a function of what type of crops you are utilizing. These methods, whether you are using the ditch or whether you are using the perforated pipe, underground pipe for the subsurface irrigation, in general you will find that the suitability of this method is not used at many places. There are a lot of restrictions in the sense that you have to use this method where you have the water table is quite high, you cannot use this method where the water tables are very low, because as we have discussed that it can lose a lot of water and as deep percolation. You should use this method only when the salinity is quite low, because if the salinity is high, then by what it does is that since the water table in that area will be already very high, now as you use this method, the chances of evaporation, because the water will be coming to the top of the ground level because of the capillary rise, as that is one of the way by which your root system is getting water. So if the salinity is very high, the chances of salts coming to the top of the soil is very high because of the evaporation from the soil. So you avoid this method when you have the low the high salinity in the water. Then you should avoid this method. Then is suitable when the soil surface is leveled, because this method, the type of control which you are talking about, if the area is having a lot of slope, then the ditches won't function very well. Especially in the case of ditches, you are trying to have the ditches where the water is only being maintained with respect to the input which you are giving into the ditch, and the levels are maintained from one area to another area. You don't make the water run with velocity, is only maintaining the levels of the water. So most of the time you will try to use this method when the areas are very well leveled, they are flat areas, and you're not bothered about the flow of water, because you are making the water, they are all interconnected ditches. So once you put the water in one location, the water will automatically move into the other locations also, and this method is quite successful when you have that type of topography. To give you an example, this method is very successful in Holland. In Holland, as you might be knowing that the Holland, the general level is below the mean sea level. So there they are using a lot of dikes to keep the seawater away from their land. And there, for the floriculture, the tulip cultivation is being done using this method of the ditch, the subsurface irrigation method. There you will find that the water table is already excessively high, so they are controlling the water in the ditch and maintaining that level either by pumping the water out of the ditch most of the time, so that they can keep the level at a desirable level. Then another suitable condition should be that the soils should be relatively porous, so that you don't have to use very small spacing between the ditches. Your spacing, to have the spacing large enough, you should have the soils which are porous soils, so that the water can really travel fast within the ground, and it can stabilize, maintain that level which you are trying to control. So from those angles, I think you will get a feeling that this method is again a method which has a lot of restrictions, and it cannot be a method of very usual nature. It is a specific purpose method with a suitability only in those circumstances where you have these conditions met. Let's go to the last class of methods which we had defined at the beginning. That was pressurized irrigation. Pressurized irrigation method. This method is, in general, is the one where your application of water as through pressure devices. And again, as far as the distinction between the surface and subsurface is concerned, this method is in general a surface irrigation method. You are applying the water onto the surface of the land, onto the ground surface, whereas in some cases you might find that, especially in the case of drip irrigation system, we will come to that, you might be supplying water not exactly on the surface but maybe slightly below the surface, but that is again the level is very small, and that is for us with a specific purpose. But in even in that case it will be called a surface irrigation method. So between the first two categories, this will belong to the first category, or with the only distinction that you are application of water is through the pressure devices. That means ultimately when it comes to the application stage is through the pressure device. Because of that requirement, even the previous system, the whole system, you have to have under pressure, otherwise you don't have any other means to provide that ultimate pressure at the application level. So it becomes essential that you have the pipes, the water will be flowing through the pipes, the source from the supply source, you will have to carry the water all the way under pressure, so that ultimately when you come to the application level, you might use any type of device, but the water should be still under pressure so that you can supply that water under pressure. So that is the basic difference between this method and the previous methods we have discussed. There are many different variations of this pressurized irrigation method. They can be different categories. They are either dependent on what type of devices you are using, or what is the order of magnitude of the pressure. that is how the devices will also be varying. There are many classes of such systems, but the two which have become highly popular, we'll discuss those, and these are, first one is sprinkler irrigation system, and the other one is drip irrigation. These two methods are the ones which are basically the basic reasons why these methods have come into picture, why they have been they have come into being, is the scarcity of water. That was the basic reason that people thought of different ways of saving water, and by doing so they felt that if they use the sprinkler irrigation in comparison to the drip method, the saving is not much. That has been found later on, but the intention was to save water. That was the first intention. But the drip irrigation is the further refinement of, not the refinement, but the further research into how you can save water, and those circumstances where the water availability is a limited quantity, and how you can make use of that limited quantity of water to get the maximum or the maximum yield per unit water. With that objective, this method came into being. And Israel is the country where the sprinkler irrigation as well as drip irrigation method has been. They have pioneered these the pressurized systems, and even now I think they are one of the leaders in these two irrigation methods. Let's look at these methods one by one. First, let's have a look at sprinkler. Sorry. Sprinkler method. And this method the water is supplied through the pipe network, as we have said that ultimately the device for application to be used in this particular case is the sprinkler head. Now, the sprinkler head is a device which sprinkles the water. The name suggests that it sprinkles the water over the surface of the ground. And you might have seen the sprinkler heads working in some of the gardens these days, some of the lawns, and there are sprinklers which are a very small sprinklers which can be used in the lawns, which can be used with the tap water which you are getting in your houses. So that device is called the sprinkler head. This device has a sprinkler head, which is nothing but there are different types of sprinkler heads. It is a device which lets the water go out. Since the water is under pressure, it goes out in the form of a jet, and that jet is broken with some mechanism so that it gets distributed in different droplets. So that is the basic philosophy of the sprinkler head. It disintegrates a steam jet into smaller water particles, and those water particles are sprinkled over the ground. So you can either have a single nozzle head, or you might have a double nozzle head where you have two jets coming simultaneously, and they are distributing the water over the whole area. So this sprinkler head, it rotates around its axis in a circular with a circular motion, and that motion can also be changed, it can be fixed. So if you look at the plan, if you have a sprinkler head here, the spread of the sprinkler head will be a circular area, and if I look at the distribution, how much water has been distributed, this is the axis where I have located the sprinkler head, and this is the distance in both sides. The spread might be something like this. This is known as the distribution pattern. This is the distribution pattern of a single sprinkler head. Okay. So when the sprinkler head will be sprinkling water in this total area, this is I have taken a section view at this level. Even if you take the section at this level, you might have a similar section. And this is what is the basic philosophy of what the sprinkler head does. Now you might say that if this is the distribution of a single sprinkler head, then this is quite an uneven distribution. We started with thinking of those methods by which we can have a uniform distribution for the total field. For example, this was the field, we had this was our root zone depth. We wanted a uniform distribution over this whole area, and in the surface irrigation methods we have seen that we cannot achieve this because of the fact that the water flows from the upstream end to the downstream end, and that's why there is uneven distribution, because this gets more water, the upstream end segment of the field gets more water than the downstream end. So this can be avoided with this sprinkler irrigation method. Now in this case, what I want to do is, I want to spread if this is my total longitudinal direction, I might try to have the sprinkler heads spaced in such a manner that I get, when I try to overlap, each one has its own distribution pattern, the other one also has its own distribution pattern, the third one, and so on. When I look at the distribution pattern of the total combination, the end result is the combination of all these distribution patterns, and I might get something of this nature. Okay. So is the overlap which is important, that how each individual sprinkler head which is spaced at some spacing, that spacing is important. That spacing is what we are interested in knowing. That is part of the design. When you design the sprinkler system, later on we'll see that there is something which we want to look into. What should be the spacing? Because that will be a function of what will be the distribution pattern. Distribution pattern can change with respect to the pressure, with respect to the nozzle size, and these are the two major factors which will decide what will be the sprinkler, what will be the distribution pattern of a sprinkler head. But this is the basic philosophy. Similarly, this overlap, this is one overlap in one direction. Let me put the whole thing in plan. If I show the field in plan, now I might locate the sprinkler heads in such a way that this overlap which I am trying to look at, which will give me a good distribution, uniform distribution, will have to be considered in both the directions. So if I consider these two rows of sprinkler nozzles, and I look at the overlap of both these rows, then in both the directions I might get a good distribution of water, which is the desired distribution. So this is what is done, that you are trying to find out what is the, now I'm drawing the pipeline for this field and plan again to achieve these individual sprinkler head distributions. I might have, let me use another shade. I might have one pipeline running here, another pipeline running here, and this might be the total layout of my pipeline, which is getting which is connected to another bigger pipeline. Now on each of these locations I have, these are the nozzle heads which are located at some spacing. So my design parameters will be, what will be the spacing between the nozzle head, let me say L, what is the spacing between these two pipes, and each one, this is normally the nomenclature is that this is called lateral, is the lateral pipe on which you are installing these sprinkler heads. So what is the spacing between the sprinkler heads? Why is the spacing between the laterals? That has to be decided on the basis of what is the distribution pattern of each individual sprinkler head and what spacings are needed to have a uniform distribution. That is what you do in the case of a sprinkler system. And then the other design parameters can be the sizes of these pipes, and because that will depend on how much are the losses in terms of the pressure variations, because since we have just mentioned that the distribution pattern will be a function of the pressure available. So if the pressure drops very much, your distribution pattern will be affected. So all those things will come to later on, but at this stage we are just trying to see what is being done in this particular method. Now, having known this, let's look at the suitability of this method. What are the various conditions under which this can be suitable, or first of all, let's look at some of the advantages. Which will also cover the conditions under which this method can be suitable. What can be the possible advantages? The first advantage is that you have complete control on the supply of water. Complete control on operation in terms of, if you want to run the system for a very short period, you can afford to do in this particular method, which was not possible in the case of surface irrigation method. In the case of surface irrigation method, if you, it might not be feasible, but if you are willing to apply a depth of 1 centimeter of water, it may not be possible. In some soils, it may not be at all possible, because while doing so, you might find that you have created a lot of disparity in the amount of water which has been ultimately made available at the upstream end and the downstream end. Whereas in this case, you can run the system for a very short period, and you can afford to apply any depth which you find feasible, or you want to apply that depth onto a particular area, you can afford to do that. Then the other advantage is that you can use this for very coarse soils, where no other method is suitable, because if the soil is very coarse, now in this case you are not supplying the water from one end to the other end. Since it's coming as in the form of rain, as the rain comes, you can apply onto any type of soil, whether it's a highly porous soil, or even if it is the other extreme, where you have very low infiltration rates. In that case, what is needed? If you have very low infiltration rates, if you use a conventional surface irrigation method, you might find that most of the water is getting lost in the form of runoff. Whereas in this case, you can afford to reduce the supply. The design can be made in such a way that the rate of input or the rate of application can be reduced, and over and above that, you can have more intermittent irrigations. You can have more frequent irrigations, which is not possible with the other method. So in this case, you can have this method suitable for very coarse soils as well as very fine soils. And if it comes to that situation, but at the same time, if the amount of water which is or the level of application is very high, then I think it's not worthwhile going in for this method, because if the level of water application is very excessive, then it's better to flood the area than going in for such a method. Then in this case, you no need of any leveling. So the land leveling, you can use this method for undulating areas where no other surface irrigation method is possible or is useful. You can use this method because in this case you don't have any problem of the terrain, as the application, the rate of application is in your hand. You can wait for the soil to be dry so that next time when you apply the irrigation water, there is no surface runoff. In the beginning, the infiltration rates will be high. So unless you have reached a steady state infiltration rate, you will find that most of the time in most of the soils, the infiltration rates will be comparatively higher. So in this method, you can afford to make use of those advantages, and you don't, the mere fact that the leveling is not required, that is a big boon. So with that, I think we'll stop here today, and we'll in the next class we'll continue with this and go on to the next method of drip irrigation. Thank you.